Hello, everybody. We are about to get started. Get all this ready here. How's everyone doing today? As we always say when we get started, feel free to go ahead and get your comments in. As we're doing the class, if you have any questions, anything you want to add, um, I should be able to see everything. So go ahead and ask as we're going through it. We'll also open up for a Q&A, but I want to make sure that everyone gets to ask any questions they have, and we can get through it. Just giving it a couple, just one more minute as we get set up here. It's gonna be a little bit different today because we're gonna just do basic wiring schematic training, so it's not anything that we're doing in the lab area. So we're in my awesome office. All right, all right. So we're gonna go ahead and get started, and I do want to touch base on what it is that we are going to be talking about today as far as basic wiring schematic training. There is a huge difference in understanding what electricity is and how it flows through a circuit and what reading a schematic is. You Without number one, you can't get to number two. So basic wiring schematic training is something that we usually do second to understanding what electricity is and how it travels through a circuit, what voltage is, amperage, wattage, and all these kind of things. You have to understand how electricity works in a circuit before you can actually get into wiring schematics. Otherwise, think about it as well, a roadmap. And that's really what, schematics are. They're a roadmap to kind of teach you and, show you where everything's going. Well, imagine if you are trying to learn how to read a roadmap, but you haven't learned how to drive or even how a car works. Without knowing how to drive and how to get from point A to point B, well, then the roadmap doesn't do anything for you. Well, that's basic wiring schematic training is, well, you kind of have to understand the other side of it first. This was, of course, put in as a request on our last training class. So we are going to talk about how to read a schematic, but if you don't already know how electricity works, then some of it might not really connect. So we do teach basic electrical theory first before we get into these steps. So hopefully you have some knowledge on how to use a meter and what the voltage potentials are and what amperage is and of wattage, resistance, and how to use Ohm's law. Those are the kind of things you should already know before you get into learning how to read a wiring schematic. I speak from experience. As somebody, when I was learning how to work on appliance repair, unfortunately, I wasn't properly trained on how to read a wiring schematic or how electricity works. The trainer that I had at the time also, wasn't aware of how these things worked as well. So it was something that I kind of skipped over and tried to teach myself on how to read a wiring schematic. And I attended several classes and spoke to several people who, kind of taught wiring schematic. And there was always this piece missing, and things just didn't click for me. And that was because I was missing that important, step of understanding electrical theory, which is number one before getting into all the madness of learning wiring schematics. So I want to make sure that you guys understand what it is that we are going to be talking about today and the importance of understanding how to read a wiring schematic when it comes to appliance repair and HVAC systems and everything that we do as tradesmen. Wiring schematics are a vital tool that you have to understand how to read them. Otherwise, you can, end up being somebody who's changing parts and not understanding how to properly test the system because you're missing that vital information in your head of how to read that schematic. So, wiring schematics is extremely important in what we do in our, daily lives when it comes to working on appliances and HVAC systems and other components, mechanics, everything kind of need to know how to read a wiring schematic. So we're going to get into all that here. Let me get my presentation up. I'm going to share my screen here with you guys, and we are going to get into it. Just waiting for it to load here, one step at a time. Is everyone able to hear me? I see a message. Can't hear a thing, but I haven't heard anyone else say it, so might need to turn your volume up. All right, here we go. And hopefully you are seeing the presentation here, and I should be itty bitty right in the corner. All right. So this is going to be basic wiring schematic training. We are going to look at some wiring schematics, but first we want to just talk about um, some of the basics when we're talking about, these schematics. Let's get through it here. All right. Oh, went too far. There we go. So let's start by talking about what is a wiring schematic. So as you can see here, wiring schematics, also known as electrical schematics or circuit diagrams, are graphical representations of electrical circuits. They use standardized symbols and lines to depict the components and connections within a circuit. So really, we're going to talk about the difference between some manufacturers. There are some standardized symbols and ways that these schematics are laid out. Every manufacturer has their own standardized way of doing things. Most symbols, I'm not going to say all symbols, are standardized across all manufacturers and all things. Um, but we are going to talk about the very basic ones, the ones that you will see everywhere. But just keep in mind that, there might be some differences between manufacturers. So let's talk about what the purpose of wiring schematics are. So why do we need them? Number one, visual representation. It provides a clear and visual representation of how the electrical components are interconnected. Without us knowing, when you're looking at a component, you could have a couple wires coming out of a component, but you might not know where it's going and how to trace it. Just because it might have a blue and yellow wire to that component or that load, it might not be that same wire at the control or different connectors. And it's important to understand how to read that schematic to kind of know where things change. It also allows technicians to understand the circuit layout and the flow of the current. Number two, troubleshooting. That's what we use it for. It's an essential tool for diagnosing and repairing electrical faults in appliances, and it helps identifying where a circuit might be broken or malfunctioning. I'm I'm guilty of this. Like I said, when I was learning appliance repair, unfortunately, you might not always have the best trainer that can teach you on, wiring schematics and electrical theory. Um, I wasn't gifted with that. That took hard work and determination to get. Um, and when it comes to that, is you're replacing a part, you're replacing a control, but because you don't know how to read a wiring schematic and how to use it to properly troubleshoot something, you might not understand how to test that system, maybe for a broken wire in that circuit or understanding any of those things. So troubleshooting is, vital when it comes to wiring schematics. Standardization, number three here. Like I said, this can change between manufacturers, but it ensures consistencies and understanding across different technicians and engineers. Um, Engineers tend to stick to standardized symbols and color coding and things like that when they're in the same group. And when I say same group, we're talking manufacturer. A tan wire at Whirlpool might say T as in Tango, N as in November, and they might label it as that. But you go over to GE or Frigidaire and other manufacturers, that tan wire might have a different color code um, that's different from Whirlpool. Whirlpool and other manufacturers, they all have their own standardized labeling of components and things of that nature. So keep that in mind when we talked about standardization. Also, use standardized symbols and notations, making it easier to communicate complex electrical, information. There's general symbols that all engineers use. We're going to talk about some of these very standard that you will see across every manufacturer. Um, and if you really learn the basics, you can get through just about any type of manufacturer layout of their schematic, their symbols, their color coding. You kind of get through that. And that's when it comes to number four here is our documentation, which serves as official documentation to, for the design and the functionality of the electrical systems. Documentation in schematics is vital. Uh, they can kind of paint a picture or tell you what you're really looking at when you're kind of stepping out of that standardization that you typically see in one manufacturer. Other manufacturers kind of give you charts. If they're using different color coding for their wiring, they'll provide you with this information in their schematics. So documentation is also really important, useful for future reference and modifications or upgrades as well. So documentation is, very really important to understand, to look at that. I've seen a lot of technicians, they see the wiring schematic in front of them and they ignore all the writing around it that is telling them how to read that wiring schematic. And then lastly, number five here is safety. It provides detailed information on the correct connections and configurations, helping to prevent electrical hazards. You're going to get shocked. That is going to happen. It's just a matter of when. But safety is always first. When you're dealing with electrical circuits, if you are testing properly, you should be testing it under load. I'm not somebody who pushes to test continuity or resistance because those kind of things can lie under load. Those situations can change. So I've always taught to, um, when you're checking an electrical circuit, you are doing that circuit live, unless, of course, it's an unsafe way of testing, related to microwaves and the high side of our electrical circuits. You can't test that with a live load. So you are kind of, you know dead in the water when it comes to that, and you have to test it by resistance, ohms, and continuity and things like of that nature. But outside of that, I try to push to test things with a live electrical circuit. So, make sure that you are staying safe when you're dealing with electrical circuits. And as I said before, read the writing around your schematic because they'll provide detailed information on the correct connections, and hopefully prevent any type of electrical hazards, and in assisting in assuring that the repairs and the installations are done safely and correctly. So when it comes to that, that is our five reasons, our purpose for using wiring schematics. Key elements for wiring schematics, of course, going to be our symbols representing components such as loads, capacitors, switches, relays, and so much more. We'll go over some of it. There's just not enough time in a day for us to talk about every possible symbol in a wiring schematic. Lines, which indicate electrical connections and the flow of current, and of course, our labels, providing information about component values, part numbers, and reference to designators. All right, so let's talk about the basics. We're really going to be talking about the basics today, the four main parts of a schematic. Everyone gets overwhelmed when we look at a schematic. I do all the time, especially when we look at something that can take over a whole table. I've opened up some units and pulled that tech sheet out and laid it out on the table, and that wiring schematic was so big it took the customer's dining room table. There's ways to prevent to avoid getting stressed out or overwhelmed by what you're looking at. You follow the four main parts of a schematic, and that is going to be your source, your path, your control and switches, and your loads. Those are your four main components that make up any and every wiring diagram and every schematic. That's it. It's just a source of power, the path where your electricity will flow, your current will flow, your control and switches, and of course your loads. That's it. Everything else is just wiring. and you're just going from point A to point B. That's it. But we tend to forget that when we're looking at these schematics and we get overwhelmed by what we're looking at. And this doesn't mean that you're going to follow this as one, two, three, and four. You might not always start at the source, go through a path, go through a control and switch to find your load. You might sometimes start at a load, go through your load, find through the path to your control and switches, which will then provide you where your source is. Sometimes, depending on the type of schematic you're looking at, you have to start at the load. There might be so much wiring and spaghetti in front of you that you have to start at the load and work your way back to the source. So it's important to just kind of understand that there's four main parts. It doesn't mean that you have to follow them as, steps one through four. Now let's talk about understanding the difference between the wiring schematics, a wiring diagram, and circuit diagrams. Yes, there is a difference between the three. Let's kind of look at some examples. So right here on the top, I tend to use this as my main example just because Whirlpool does provide it, right next to each other. But if you're looking at it, you'll notice that there's a difference between a schematic and a wiring diagram. These right here next to each other, they're the same unit, they're the same diagram, they're the same everything. The difference is one side called the wiring diagram, and you'll see the other manufacturers doing this as well. Wiring diagrams give you everything. They let you know where every wire on that unit is, where every splice, where every connection, where every load, everything is. And then the schematic is a simplified version of that wiring diagram. The schematic is written as the electrons see the circuit from point A to point B. That is it. You're not going to see every wiring connection because electrons don't care about every wiring connection. They're trying to get from point A to point B. In reality, electrons are just trying to go home. They're just trying to find their way home. And for them to find their way home, they're just going to go from P3 all the way to, of course, to your line. And yes, we travel, electrons travel from negative to positive. Um, of course, conventional electrical theory always indicated that, we flow positive to negative, but in reality, we do flow from negative to positive. So electrons are just trying to find their way home. Over here in the wiring diagram, the electrons don't care that there's several splices and multiple wires to go the same route. It is going to find its way home. So it you have to understand how to read both the simplified version of the schematic and the wiring diagram, which is where all the spaghetti is. Um, the wiring diagram really comes in handy when you're dealing with a potential break in a wire, or sometimes even something that could be inside of a cabinet that you don't have access to. Understanding how to test it and how to read that wiring diagram, you might find out, hey, I got voltage on this side of my circuit, but I don't have it here. I got to figure out where I'm broken. And, seeing where all these wires are going, you can easily pinpoint where you're going to, put your meter leads and find your answer. And you can pinpoint exactly which wire and which circuit is broken or damaged. Something that you're not going to be able to do by reading the schematic. Then we get into strip circuits. Well, strip circuits are not always available. I know Whirlpool is not huge on strip circuits. Um, they're real big on their dishwashers, but it's not something I see in their refrigerators. I have seen Samsung do some strip circuits, but they really lean towards more wiring diagrams. Um, LG, I believe, does the same. GE does do a lot of schematics. But strip circuits are just a simplified version of one circuit. And we're taking one circuit out of this whole picture and we're breaking it down so you can see just that one circuit. So this is on a dishwasher and this is a drain motor on a dishwasher, and we'll look at that a little bit further here. But looking at this here, you'll see you got your line one, you got your neutral, and you got your load. And of course, here's your electronic control, and this is the other side of the electronic control. Um, that is one circuit. This is just a even more simplified version than a schematic. Just for you to pretty much just focus on your load of interest. So if you're only worried about your drain pump or your wash motor, you don't have to look at a full schematic. Some manufacturers do provide you with strip circuits, and you do have to understand that there is a difference when reading those. Um, it is just one single circuit. As you can see here, even though these are on the opposite sides of our load, the P5 and pin 4 and pin 3, they're all right next to each other, right on the same control board. And some technicians might look at this as two separate parts or two separate controls. They're not. These are the same control, and that's why it's important to understand what you're looking at when you're looking at a strip circuit diagram. And we'll go a little bit further, and I got some examples here on dishwashers and why strip circuits are sometimes more valuable or sometimes even can help you speed up through your diagnosis. All right, so let's now bring in the symbols. Let's talk about common symbols and notations that you'll typically see. Just have some examples here, but let's talk about some of the most common ones. And I do want to throw out there that I am going to be sharing a link to a training manual that I've always used that was used to help train me at one point. It's also what I use to help train other technicians. I will be sharing this with you guys that you guys can also um, go back and review and there's way more symbols in there as well because there's like I said there's just not enough hours in a day for me to go over every potential electrical symbol. So let's talk about the most common ones you will see and how to not get confused by what you're looking at. So let's talk about your plain conductor is just going to be a plain, simple line that is representing your wires. Then you have crossovers. Now, um, some manufacturers will do a typical cross like you see right here. These are not permanently connected wires. These wires are crossing over each other. They're not connected. Electricity is not flowing from this wire up to this wire. They're completely separate. Just think about an overpass. You like I said when you're relating to driving, you know, you have one overpass over the main road below. There's no way for you to kind of hit each other. They're totally different. And you kind of look at this crossover here. They actually added a little hump to help you see that hey, this goes over this wire. They're not permanently connected. You have shields and mechanical connections here. Typically see these kind of symbols related to parts on a schematic might not be uh, that might depend on the model. They might do a dotted line and say it might vary by model that this component might not be on the model you're working on. Kind of look into that here in a moment as well. Then we actually talk about permanent connections, black dots, the little black dots that you see on schematics. Those are permanent connections. That means that those wires are permanently connected to each other in the in your wiring, in your harnesses and things. Most times, manufacturers will add a little box and it will say splice. Some manufacturers might not add that little box. They might just use a black dot to let you know that all these wires are spliced together. That's what these black dots mean. They mean permanent connection, which are different than the white dots. White dots in wiring schematics mean that there are terminal connections that you can unplug, that you can service. These are not permanently attached to multiple wires. These are usually terminal connectors to a load or to a control board or things of that nature. You got your ground earth and your chassis ground. Those are different. Uh, ground chassis that is directly to the chassis of the product. Ground earth is going straight to the ground. That's going to the plug. That is going to your breaker box. That is then going to outside your house into a rod into the ground. So there lies the difference between the two. Plug connectors. Typically see these plug connectors. We've probably seen them all. The Mullix connectors. I'm going to use that for example. Mullix connectors. You have JST connectors, all different type of connectors, but that's what it means. When you're looking at a schematic and you see the symbol, that means that there's a plug connector that you can undo. That is different from a terminal connector, like a spade terminal connector. It is different to your Molex and JST plugs and things of that nature. You got, of course, grounded service cord, three prong. Don't typically see these in schematics. Um, Newer schematics, of course. You might see these on dryers, but they don't look like this. Like they're real close to together. They're more spaced out. Those little arrows are spaced out, and then we'll show that here in a little while. But that's what we're talking about. We have, your standard coils, and of course, coils may also be shown with an open loop, as in the following examples down right here where a solenoid is. You'll see that the loop is more open. Standard coils, fuse, heaters, or resistors. I know, Whirlpool loves to use the heater and resistor symbol almost identical. Sometimes it's hard to understand. Are you looking at a heater or a resistor? Thankfully, they do add a little word right below it. If it's a heater, they'll say heater. Uh, Probably seen these symbols on GEs, LGs, and things like that. For their heaters as well. Thermistors. Now, this symbol is not totally complete. Most thermistors, you will see a line through them, and next to the T, you'll have a minus or a plus to let you know if this is a NTC, negative temperature coefficient thermistor, or if it has a plus sign, that'll let you know it's a PTC, positive temperature coefficient thermistor. And for those that don't know, a PTC thermistor, as the temperature goes up, so does the resistance. That's vice versa on our NTC, negative temperature coefficient, whereas temperature goes down, resistance rises. So it's different. So make sure that when you're looking at your schematic, you'll even be able to know, does this unit use a NTC thermistor or PTC thermistor? So when you're checking resistance, you know what's happening. Is it cooling? Is it warming? What's happening to that thermistor? The schematics, they have these things there to really show you what's happening. And you have diodes, of course. Diodes, a permanent current flow in one direction only. Um, we, believe it or not, the most common diode that every single one of you guys probably see is an LED, a light emitting diode. And then you have triacs, which are electronic devices similar to a diode, except it allows current to flow in both directions. Um, think about it as like not really like a relay, but electronic switch that's built into your control. You have to power, you have a gate, you have to send a signal, you got to have a load through this triac for it to be able to flow electricity. There's a whole class that I can do on triacs and how to properly diagnose and how they work. Then you have, of course, motors. As you can see here, we have standard motors, single speed, two speed, three speed. These little coils, as you can see up here, coils. These are going to be your different windings. So if you're dealing with a two-speed motor, you do have two separate windings. Three-speed, these are going to be the individual windings of the motor. So just wanted to get the basics to kind of show you guys, and then we're going to actually look at it on a schematic and how to understand how this works. All right, let's get all this out of the way. And let's get, where did my stuff go here? There we go. All right, and I'm going to go ahead and put this in the comments section. I recommend everyone save this link. Use this link, put this link on your browser, bookmark it. This is where you can go to really look at all the symbols and different things like that. Now, this is designed by Whirlpool. Um, if you're in Service Matters, if you have access to Service Matters, it's just a matter of typing the word electrical theory, and this whole booklet can pop up. These are old training manuals, and I mean old training manuals. Electrical theory hasn't changed. Appliance theory hasn't changed since appliances were first introduced. So electrical theory is pretty much all the same. Get out of my way. All right, and just to kind of just show you guys here, really what it gets into, it pretty much walks you through understanding electrical theory, what each type of electrical energy does and how to measure it, goes into Ohm's law. It kind of covers everything. But what I want to show you guys here before we jump out of this is that there's a section in this booklet that goes over all the symbols. Now, like I said, it's a little dated. So some of these symbols are not something that you might see in the field currently, but there is all kinds, and it goes into parallel circuits, series circuits, and all types of different types of circuits, and kind of even there's a little test section to see if you can test yourself. But let's get down here to the symbols. This thing, it is huge, by the way, so be prepared. All right. And let's get into the wiring diagram section. They kind of give you some, like a glossary here to kind of talk about terminology, um, and gets you into color coding. Again, this is just Whirlpool's color coding, so you can't use this on every manufacturer, but they do have the symbols. Symbols don't really change that often, so they have every symbol that you typically will see. They have it on here. There's several of them. Um, from motors, thermal switches, all kinds of different loads. And then there's even a section here that you can kind of, what I used to do is kind of test myself, and they have a blank section here. Let me get to that. There you go. And you kind of have to write down what each symbol is, and then you can kind of, there's an answer sheet and kind of test yourself to it. So it's a great tool to have when you're trying to learn how to read diagrams and learn electrical theory. So I strongly recommend you guys copy. I posted in the comments, so you should be able to see it. But let's jump in and let's talk about everything that we've learned and how it works on a diagram. Let me zoom in here. As we talked about permanent connections, terminal connectors, I'm just zooming in. See, those here's our black dots. These are permanent connections. I cannot disconnect these connectors here. These are permanent connections. White dots. Now, these little white dots over here, let me zoom in over there. As we talked about, too far. There we go. These little white dots, these are terminal connections. I can disconnect these wires. These are, of course, door switches, and I can disconnect these wires. These door switches, where these black dots, these are permanent connections. That means electricity can flow, not just, let me just get a pin here. If electricity is flowing this way, for example, it is not just going to go to my switch. But because I have these permanent connections here and here, that means that the electricity can flow, current will flow through every connected wire. And that's what these permanent connections are. These little black dots mean that I can flow current through it in all positions. Each position, um, man, my computer is being super slow. All right, let's clear this up here. All right, and let's kind of zoom out and let's talk about, you know, like we said, the schematic to the wiring side. What's the difference? How does it work? And then we'll get into some more simplified schematics where we can actually trace it out and understand how it's flowing. And here is the spaghetti. Here is the wiring side. you know of course nothing's going to change. We have these little black dots, and like I said, sometimes they'll include some documentation to kind of help you out a little bit. They're telling you that there's a splice here, and then permanent connections, you can't disconnect those. And these, of course, these are our plugs. Now, this is something I wanted to talk about because not every manufacturer does this. Only a few that I've seen that will kind of guide you through it, which is These little bars right here, let me get a little bit closer so y'all can see. These bars, these bars right here. That is not that is not labeled in any type of electrical theory book that I've found or any type of symbol book I found. These are symbols that only certain manufacturers use. I know Whirlpool's one of them. Those are symbols to let you know when you're coming in and out of the liner of a or a cabinet of an appliance. This is a refrigerator, so every time you see this little square, what that's telling you is where you're coming out of the liner and when you're re-entering the liner. So this is actually the line inside the cabinet here. So on this side is where you're coming out of the cabinet, out of the liner. So it's important to understand what these little symbols are because when you're looking at it and you got the appliance in front of you, you need to know where these plugs are, right? It doesn't help me if I'm looking for, as you can see here, let's use this one for example. I'm looking for a 4-pin plug with a black and white, a green and yellow, and a white wire. I'm gonna have to look at every single little 4-pin plug on this dang refrigerator to find that. Or I can kind of understand and look at the documentation, as we talked about before, understanding the documentation that the manufacturers kind of put up here for you to, so you can kind of know where you're at. Whirlpool does pretty good for the most part as far as telling you where you're going and where you're at. Not every appliance. Let me just clarify that. Not every appliance do they do this for. All right. There's some of these appliances that I would love to talk to that engineer who wrote that and say, buddy, look, what the hell? All right, I can't read none of this. There's some of them they just throw it all on a piece of paper and say good luck, but then there's some that are really well written. And they have some documentation. You can see to the fascia heater. That lets me know I'm coming out of the liner to my fascia heater. Here's my fascia heater. Of course, here's another one. Here's this big square. What does this big square mean? Well, that's my ice box. They kind of have some documentation. Here's my pantry LED. That lets me know I'm coming out of the cabinet, going to, I got a 2-pin plug, a 4-pin plug, and then I'm re entering right here. I'm re entering the liner. This is all inside the liner. Well, I'm sorry, coming out of the liner. So I go in and out into the liner and I'm coming out, and then I can get to my pantry LEDs. So documentation, every schematic does have documentation all the way around that can really help you. So just make sure that you are paying attention to those all the pretty much the road signs, like going right back to driving, there's some road signs that you got to pay attention. So let's come out of this schematic and let's get into a little bit more simpler versions of these schematics. And I want to talk about the strip circuits and the wiring schematics on the dishwasher. So here's a dishwasher wiring schematic, one of the more simplest. Anything related to washing machines, dishwashers, even dryers. They're pretty simple. Anything that's electronically controlled, you're basically looking at this. You have one control, and let me just highlight, you know, again, documentation. This is telling me where my electronic control is. Everything in this dotted line in this shield here is my control. And then all my loads, here's all my loads, are coming off of my control. Not really that, intense, not that difficult to really translate and understand. It's very simple for the most part. But there's several loads. There's several loads when you're looking at this control board. There's several loads here. And that's when, some manufacturers might give you individual strip circuits, like this drain pump right here. If I was looking, let's say I'm a, novice to understanding wiring schematics and things of that nature, this might be a little bit too much for me. I might take a minute to really kind of go one by one to figure out where my drain pump is. But some manufacturers, they will simplify it and give you a strip circuit. So this is the strip circuit of that drain pump that we just looked at off of the P53, P54. Let's go back to the main one. This is our P5 connector right there. Now I'm just going to zoom in just into this circuit since we're talking about it. And we're going to actually trace this circuit out so you can understand how it's flowing through the circuit, how the current's flowing. Now, let me erase all my chicken scratch here. All right. So as we talked about that P5, 3, and 4, let's go back and look at that strip circuit again. Here's my strip circuit. Again, this is P53, P54. How it might look like two different controls because it's electronic control on this side, electronic control on this side. But in reality, it's all one control. And let's talk about why it's broken up this way. Let's go back to the schematic. Here we go. Here's our drain pump. Again, P5. Let me get my highlighter out again. P5 there, 3 and 4. That's a terrible highlighter. That damn thing isn't doing anything for me. Look at that. Just nothing. Anyway, let's trace it out so we can kind of understand why it kind of looks like two separate controls on each side of that load, but in reality we're talking about one control. So like I said, break it down into your four main parts. You have your source, your path, controls and switches, and your load. You don't always have to follow, steps one through four. You can kind of just start at the load and work your way back to your source. And we're going to do that here. So let's start right here. This should be our power line here, our L1 side, our line side, and we're going to come through. All right. Now we got a black dot. That is a permanent connection as we talked about. That means that line 1 is coming down this wire and it's providing L1 to all the loads at the same time. Each load is being controlled by triacs on the neutral side of the circuit. And we're going to see that on our drain motor here. But let's finish tracing this out on our drain motor. We're going to trace it out. Oh, we got a hump. That is a crossover. That is not a permanent connection. We're going to keep going. We now have a fuse. We're going to go through the fuse unless that fuse was open. We have another permanent connection. That means, our L1 will kind of come down here and go to one side of our motor. I'm not going to trace that circuit out, but just to let you know, there is a permanent connection there. And we're going to go through our pilot relay. Now, our pilot relay on these dishwashers, they're normally open. As you can see here, until you start the unit, then you're closing that relay, sending that L1 side of the line down to all your loads, and then you are cycling your loads on and off and monitoring your loads through the triacs. So let's keep following this here. And here's our permanent connection that I want to talk about because this is where our source comes in from. As you can see, now we will still go this way with our L1 till we get to our heater relay. And our heater relay is in the open position. It's written in the open position. Um, when you're dealing with microwaves and things of that nature, things that have doors, it's important to really look at those documentations because they will tell you the way that the schematic is written. Because not every schematic is written, with the door open or door closed. You have to look at those documentations, and they'll kind of describe to you um, it, what position these switches are in. But right back here, that's our line 1 and it's coming through a fuse directly to L1. As you can see, it says L1 there. Now on neutral side, if we trace that, we have, of course, another crossover, and we are back at the relay. Not the relay, our triac. It doesn't show, of course, but there's a gate, and then we have permanent connection, and then we have the triac loading current sensing circuit. So pretty much everything on this circuit, this is our neutral circuit. If we follow it through, again, another permanent connection. We're not going to chase it all the way down. We're going to do another crossover, permanent connection at our black dot, a couple of different crossovers, and we're going to keep going, keep going. Yeah, really, come on, keep going. And come on. Oh, you know what? I can't see nothing. There's a turn right here. I was going straight. I'm like, why am I going straight? Just fix this real quick. All right, we turn and go to our neutral. There we go. I was about to say, why am I going down to my heater? So there's a turn there, and we go to our neutral side of our circuit. And this control board also has two sources of power as we have a power supply here to convert our 120 circuits down to 5 volts and 12 volts, and these circuits typically go, if I want to follow this will go to all of our low voltage fan motors. You can see all these permanent connections on the low voltage side, all the way to, of course, our user interface right here, our HMI, human machine interface. So the biggest thing is understanding what the symbols are, how to follow your pretty much your roadmap, and understanding when you're looking at a strip circuit doesn't mean that there's two controls. And I've gotten this a few times. Why is the strip circuit telling me I have two controls? It's the same control. They're just two sides of the pins to give you one strip circuit, the neutral side and the line side. And I just wanted to bring this up before we get into the Q&A. We talked about documentation and some of the things that wiring schematics will kind of display for you that you really got to be paying attention to is there is several schematics out there that will give you timing charts depending on you're working on a unit that's got a timer. Make sure that you're paying attention to these documentations that are there. The engineers and manufacturers putting it there to guide you through the schematic. Otherwise, there's no way to read. This means nothing to me without this timing chart. This timing chart is step one in understanding this dryer schematic. And yes, this is a dryer. Um, and of course, they even give me a little legend that talks about, of course, our little black dot, which is a permanent splice connection. The white dot terminal uh, construction, and then we got timer construction, and of course, your main conductor and inline connections. This inline connection, I only typically see this on Whirlpool dryers. I really haven't seen them anywhere else, but I just wanted to bring up the documentation. Um, doesn't mean that you need to read everything, like their patents. That stuff doesn't really matter to you. But because you see little stuff that doesn't matter to you, you might ignore your pretty much your road signs and the things that you need to pay attention to, your documentation that's there to guide you. So we are now going to go ahead and go into our 10-minute Q&A. Again, like I said, this was a very basic um, how to read wiring schematics. Just kind of just give you understanding the symbols. This is not to teach you electrical theory. Electrical theory is its own thing. That's something that you have to sit down and one of my favorite classes to give is electrical theory. There's a lot more about electricity that you need to understand before you go into reading diagrams. Can't really understand a diagram unless you understand how electrons are flowing through a circuit and how current is affected by resistance and your potential voltages, and understanding Ohm's law and how everything kind of works together. Without understanding all that, the wiring diagrams are pretty much just a nonsense. Really, honestly, it's going to be nonsense for you unless you understand how electricity flows. So hopefully you learned something today. on how to read some of these schematics. Again, everything we covered here today can be cross-referenced across other manufacturers, symbols, color coding. Things are going to get a little iffy across manufacturers, but for the most part, symbols, how everything connects, and how to trace your circuits. That's something that you can do across anything and any manufacturer. So let's go and open up our Q&A. Our comment section is open. And also, feel free to give us some feedback on what you guys want to see next time. Again, we do have our YouTube channel, as should be up there on the screen at Hero AP Academy. You can also, and for those watching on YouTube, thank you. Um, don't forget to hit like and subscribe, right? Let's hide that and let's go and bring up our email. This is where you can also email us any type of recommendation that you want to see, future classes, anything like that. Feel free to send us an email. So give us your questions. You have any questions, anything that you guys want cleared up, feel free to type it into the comments section. Otherwise, we will kind of close it down. Let's see. I think we got something here. Are you going to do a class where you show us how to apply the wiring diagram to a diagnosis? I can do that, but again, if I'm gonna do that, then we're gonna have to teach electrical theory, and that's like a week-long event. All right, electrical theory. I don't believe in teaching electrical theory in a day. I don't believe in teaching it in 2 days. Anyone that's out there teaching electrical theory in a day or two, yeah, that's dangerous. For a lot of reasons. Electrical theory, in my opinion, um, just to understand the very basics. And I'm not saying advanced or anything. I'm talking about bare basic electrical theory. To me, that is a 5 day long event just to get to understanding the very basics of electrical theory and really understand the potential. And there's backfeed, there's floating neutrals, there's so much that you have to cover. But can I do a class where I can use the diagram to show a diagnosis? I can absolutely do that. Again, it's gonna teeter totter on electrical theory there a little bit, but I can definitely do something if that's a recommendation. We can do a whole class. Um, we can get a unit and we can use as a wiring schematic and to diagnose a failure and show you guys how to apply everything we talked about here. How to apply understanding the permanent connections, terminal connections, how to understand where you're coming in and out of the cabinet. We can definitely do something like that for sure. So, Dom Bolden, sir, yes, yes, we can. Give us your questions. Anything else? Otherwise, that might be what we do next time. That would have a good flow with today's class for sure. Just gonna leave it open here, just seeing if we got any more questions before we knock off. Let's take a look at our calendar here for the next class. Now, this one was, spaced out. We tend to do these every other week. So it next class, uh, unfortunately, because we have some training coming up in our lab area in our academy. Um, our next class will not be until the 25th. I know we tend to do these every other week, but due to upcoming training in our academy, it will be the 25th. Unfortunately, I am the only one doing it at this time, so I'm limited as a director here at Hero Academy. So our next class, unfortunately, will be on the 25th. So any feedback, make sure that you can send us, you can comment on any of our videos on YouTube. Also, send an email out to us or any recommendations at training ha@outlook.com. I think we got one question here. Thank you, Antonio. I believe we did this class for you, sir. If I remember correctly, I think you requested the schematic training. So absolutely, Antonio. We'll definitely do more. So keep an eye out for that. We will do more. Like I said, we might even do apply what we've talked about here today to an actual product. Let's go a little bit further and try to get them tied together. Um, and if I need to do electrical theory, yes, sir. Absolutely, Antonio. We will apply what we talked about here, so we can kind of keep a flow. I might do a couple of videos in electrical theory. They're not going to be too advanced because I don't want to. I don't want to do that to you guys. I don't believe that electrical theory should be broken down or provided to a person in pieces because it's dangerous, man. It's dangerous. You need to understand it the right way. So, yes, we will apply everything we talked about here, the basic wiring diagram, and we will apply it to a unit. We will trace it. There will be some back and forth with the camera work, but we will make it work. And Antonio, we will send that. That will be the next class that we do. So, that will be on the 25th of July, because I do have a couple of weeks of training here in the academy. All right. So if we don't have anything else, we will be letting everyone go. I appreciate everyone that's tuned in today and joined us here at Hero Appliance Academy, here on StreamYard and on YouTube. Thank you for coming. Thank you for connecting, and hopefully we can grow this community to share this experience with others. Um, we're all working towards a common goal of being better technicians every day. There's no reason to not share with each other and not support each other's growth. So, thank you all for coming out and enjoying it with us today. And I will see you guys on the 25th of July for our next live stream class. Thank you for coming. Y'all have a good one.